A 3,500 microcoulomb charge, or 3.5 millicoulomb charge, is moved doing 0.0780 joules of work. If it started at a potential of 100 volt, what's the final potential? Okay, well, what we'll do, our final potential is going to be the initial potential plus the change in potential, right? That's generally true, right? Or another way of writing this is our change in potential is our final potential minus our initial potential. That's another way of writing exactly the same thing, right? Okay. So we just got to figure out what the change in potential is and add that to 100, okay? And we got to be very careful because it could be either positive or negative change. Okay, so the work is Q times change in VE. Our work is negative. So we lowered its potential energy, right? Okay, and that equals 3,500 times 10 to the minus 6th. And then we're going to find the change in potential. Okay. It's going to be a negative change in potential. Let's do it though. Change in electric potential is negative 0.0780 divided by 3,500 times 10 to the minus 6th. Okay, so alpha F1, negative 0.078 in the denominator, 3,500, E minus 6. And I'm getting that the change in potential is down 22.3 volts, right? Because this is joules, that's coulombs. Joules per coulomb is volts, okay? So let's see, we moved it, I guess, toward a place where it's more negative, right? Because this is positive charge. And so we started at 100 volts, and I guess we're now at lower potential, right? So it's going to be the final potential is the initial potential plus the change in potential. So I'm going to add that to 100, and I get 77.7 volts. So what happened here was we had a place where maybe this was 100 volts, maybe this is 0 volts, maybe this is our negative side, right? And we took a positive charge and we let it move toward the negative, okay? It went from 100 to partway through here, which is 77.7. Whoops. 77.7, yeah. Ta-da. Anyway, so we moved it toward the negative, not all the way to 0, but some amount, right?